Sweet. Can everyone hear me? Yep, son.
I'm audible, which is awesome. So, hi there, you beautiful, talented people. My name's Philip, and I work for Cybereasing. I do security research, and well, that's all about me. Anyway, this talk is going to be about a Windows feature called Device Guard, and we'll find a couple of interesting ways to bypass it, many of them relating to Microsoft Office, some of them don't, and we'll find out how these techniques could help us against other things which are not Device Guard. So, because this is a device guard talk, and I'm going to say this term a bunch, let's just discover what the hell is this feature. Now, device guard is an application whitelisting feature that was introduced in Windows 10. It is actually the successor to an older feature called App Locker. And this feature is, as an application whitelisting feature, it tries to defend against an attacker that already has some kind of access to your machine. And it does so by only allowing code that's defined in a specific policy, which could be a bunch of certificates or hashes or even file names. And only that code could actually run on the machine. And this really inhibits the attacker's ability to run any code and do whatever they want on the machine, even though they could run some code. You basically can choose only from a very closed set. Now, this has a very interesting attack surface because basically you could use anything you have on a machine to try and bypass device guard, which is all code in Windows. So this feature tries to prohibit an attacker to achieving arbitrary code execution, and we'll need to define this term a bit better to understand why and how device guard works. So what does arbitrary code execution mean, at least in our context? And for me, it will be to be able to interact freely with the OS, which is mostly accomplished by just having full control of a process. And this means that I can try to ask the OS to do anything. I could have an access deny, you don't have enough privileges answer, but still I need to be able to ask the question for it, at least for me, to count as arbitrary code execution. And this could be achieved by being able to allocate code and jump to it, or by being able to call arbitrary API calls or syscalls. And of course, it's really easy to jump between these two definitions, because if you could do the one, you could just allocate code that does whatever APIs you want, and you have the APIs to allocate code. Now, this whole definition it's a bit useless when you don't have application whitelisting, because without application whitelisting, arbitrary command execution and arbitrary code execution is pretty much equivalent, because I can start an arbitrary process, so I have my own executable, my own library, my own whatever, so I just load it, and it has my code, and I can do anything I want on the machine. But this equation actually breaks the moment you implement application whitelisting. And suddenly, you can only rely on what's allowed by the application whitelisting policy, meaning that, all right, I have a really cool exploit that allows me to pop calc on my machine, and then I try to use it against some kind of machine with application whitelisting, with device guard, and I discover that I can pop calc on my target machine, and this does not help me in any way. So you can't really implement credential stealing. You can't really implement CNC very well, etc., etc. And even if you have something like a cool privilege escalation vulnerability, sometimes you don't have the ability to run your privilege escalation code because, again, it is not allowed by the policy. So this is what makes application whitelisting and device guard really strong, because you already have an attacker able to execute code of their choice on the machine, and they still can't do everything they want. Now, it's not enough that you've broken out of this whitelisting once, because let's say you're fully controlling a single process, but maybe it's in a sandbox, and you have a cool sandbox escape, but you have application whitelisting, so you could escape your sandbox with Notepad, which is absolutely useless. When you try to do lateral movement, you mostly run commands. Again, not good against application whitelisting. Same thing with persistence and privilege escalation. So you need to have a bunch of consistent methods to be able to circumvent application whitelisting if you really want to do stuff on a machine. So this was application whitelisting in general. So let's have a little look at what device guard itself does on a Windows 10 machine. So the first thing, the first way to execute code device guard protects against is PE files. And that's very straightforward. If your PE file is not allowed by the policy, it will not be executed unless you have some kind of vulnerability. This is a bit more subtle the moment you start looking at the other types, the other code execution vectors. For example, PowerShell actually lets you execute unsigned, disallowed scripts, but they will execute in what's called constrained language mode, or CLM. And it basically takes away everything that makes PowerShell fun. All of the .NET interop, COM types, COM objects, and whatever. All of these simply disappear, and you're left with something much less useful than, you know, the former Ultimate Red Teamers toolkit. And the same thing, or a very similar thing, happens with ActiveScript engines, which are JScript, VBScript, etc. These actually only communicate with the operating system via COM objects. And when you're running an script that's not whitelisted, that's not signed, you will only be able to create a very small subset of COM objects, and none of them are useful for attackers. So even if you want to do something like wscript.shell execute, you simply won't be able. And again, this means that scripting engines are neutered. You could still run pretty boring scripts, or maybe something useful for benign reasons, but you can't really use it for offensive purposes. So if, for example, you try to double-click a disallowed PE file on a device-guarded machine, you will get this pretty blue pop-up that says, nope. And that's it, not very useful. So that was a small introduction to device guard. And one thing I want to say is that some of the bypasses I'm going to show here are actually bypasses requiring admin. And an administrative user could actually just disable device guard, but this requires a restart, and this actually throws events into an event log. And if you've taken the effort to actually implement device guard and application whitelisting on your network, on your machines, you should still really look at every single event that says, oh, device guard got disabled here, because this should really raise the sirens and should be extremely, extremely suspicious. So if we have other ways as an admin to disable or just bypass the device guard without disabling it, we're gaining basically the advantage of stealth, because if you bypass device guard for a second and then immediately get caught, this is also not very fortunate. Anyway, let's look at a couple of actual bypasses. The first few will use VBA. Now, VBA, or Visual Basic for Applications, is the scripting or the programming language that powers Office macros. And for some reason, Microsoft just doesn't instrument VBA with device guard, meaning that the moment you could run VBA, you could run any kind of VBA code, regardless of it being signed, compliant with the policy, etc. And this is pretty weird because while it's not a part of the operating system, it's pretty ubiquitous, and it is made by Microsoft. Now, if you run a macro, you're able to reach, well, my definition of arbitrary code execution. Mainly we're using two ways. The first is directly import when API functions and just use them to run shellcode or whatever. And the second is using COM objects and James Forshaw's .NET to JScript technique, which basically uses .NET interop and COM objects to load and .NET assembly into memory. So you could use any of these two the moment you're able to run a macro. But the naive way to run a macro is this, which is really lame, because you actually have to press a button, and we're talking about a post-exploitation scenario. I could already run commands on a machine. So now I'm gonna open Excel and just wait for somebody to push a button, or I don't know, RDP to a machine. That's pretty lame. And that's why I try to see if I do have any ways to run VBA macros without any user GUI interaction. So one such way is using DCOM, or basically remote COM. The macro functionality of pretty much all Office applications is exposed through DCOM, meaning that while I can't create these objects easily on my device-guarded machine, I could actually create them remotely if I have admin. And I can use these objects to run my arbitrary VBA code. I don't even need a file, actually. And this looks pretty much like this. So what I'm doing is, first of all, defining macro as a string. I'm doing a bit of WMI magic to change a small registry key on my target machine to allow me to filelessly inject VBA code into an instance of Excel. It could also be Word or anything pretty much. But I inject my macro, and then all I need to do is run it. And there's no file involved. You don't actually have a malicious document on the machine. All you have is an instance of Excel running arbitrary code on the remote machine, even though it has device guard and should be protected against that. But that required admin privileges because mostly only admins could actually reach these objects through DCOM. And that was also remotely. What I want to do is, well, let's just run a command line on my target machine and run the macro, and that's it. So I found two ways to do that. One of them is by abusing trusted documents. Basically, if you actually click this enable content button once and you run your macro, when you open your file again, you'll discover that, oh, the button doesn't exist. The macro just runs. And this is because the document is now considered trusted. But I actually opted to use the second option, which is using documents running from trusted locations and not explicitly trusted documents. Now, trusted locations are actually a bunch of folders that are managed in the registry, and pretty much all or almost all of the default ones are writable by admins, meaning that if I'm running from a trusted, even just opening a document in a trusted location, Office doesn't ask me, oh, is this allowed? Do you want to enable content? It just immediately runs everything that I want. But again, the default ones are writable by admins. And we did say that we want to do this unprivileged. So as you can see, we have here this weird ACC Wiz folder, which is writable only by admins. And this is actually the Microsoft Access trusted directory. And that's managed in the registry in this Office 16 Access security trusted locations whatever key. And as you can see, you just have the name of the folder and the path. But it's cool that it's only writable by admins. But take a short look at the actual registry path. There's a problem here, and it is HKey current user, meaning that maybe I need admin to write into the folder, but I could actually change the registry key to an arbitrary location because the current user registry hive is always accessible by the current user. So I could just ignore the identity of the actual folder and just create my own. And that's exactly what I would do. So here again, I do a bit of WMI magic to modify registry because sometimes people block reg, exe, etc. Using application whitelisting, and WMI is a bit harder to block. And all I do is just add a new trusted location for Excel or for Access. In my case, it's ctemp, and that's where I store my malicious macro. And then the moment I try to run Access with my file and try to run my macro, this weird embedding flag just prohibits Access from actually showing a GUI. So this will, of course, be invisible to the actual user. nothing stops me from just running the macro. And again, I could run arbitrary code. So these were two bypasses using VBA. And VBA is actually implemented in a library called VB7.dll. And what if we just block it? It doesn't matter which kinds of registry keys you modify. Let's just block the library itself with the device guard. Let's say it's not compliant with the policy, and then you will never be able to run VBA macros. So let's try to find something that's not based on VBA. And so we got a bit annoyed by macros because they're horrible. This is why the next step is going to be more macros. And it's going to be Excel for macros, which are actually an older legacy macro feature that only exists in Excel, and it was introduced in '92. And this is implemented in Excel.exe itself, which actually is pretty important for later. And this feature actually has call and register functions, which will allow you to call an arbitrary export from a DLL. They also have absolutely disgusting syntax. So calling arbitrary functions from DLLs is actually exactly what I want for my definition of arbitrary code. But when I first discovered Excel for macros, I actually didn't understand how to use them for shellcode because of a bunch of constraints until I discovered that Stenhag and Peter Thielen of Outflank actually were able to run shellcode via Excel for macros. What I was able to do is just run scriptlets, run command lines, etc., and this was never able to escape device guard. So the moment I can run shellcode, I could run arbitrary code, and it looks like this. Basically, we have the register function that registers into the Excel for macro all of the code injection, shellcode execution, usual suspects such as virtual lock, write process memory, and create thread, and then calls them with the appropriate arguments. The shellcode itself is actually stored in this weird value cell because while Excel doesn't really know how to display huge byte arrays, it actually knows how to store them. So it just gives me an exception and then still stores the byte array. And if I run this, I will run my shellcode. But again, we have this enable content thing. But now we do know how to bypass this. So the first version would be to use this with decom. And it's pretty simple, and it's pretty similar to the previous version. All we need to do is create Excel.application and open remote Excel file. We could actually also use this with a function called execute Excel for macro, which was actually used by Excel for decom, again by the Outflank guys. But this whole thing still had a bunch of shortcomings, and it was that shellcode running only worked for 32-bit Office because, well, the feature wasn't really implemented that well, and it caused a bunch of memory corruption stuff the moment you tried to use it for 64-bit. So I tried to implement a bit of an alternative shellcode runner using Excel for macros again. And if you're interested, just look at just enter this link, and there's a small write-up for it. Anyway, so now we can do this via decom filelessly and on 64 bits. You basically just write your payload into the memory of Excel and of a remote instance of Excel and then execute it. And you could do the same thing with a trusted folder. You again just create a new trusted folder, put your Excel for macro document in it, launch it, no GUI, no protected mode, arbitrary code execution. So the benefit of Excel for macros over VBA is that they are not implemented in a separate library, meaning that they're implemented in Excel.exe, so you can't use Excel without allowing Excel for macros. It doesn't matter how you try to play with the registry, because most of the security controls for Office actually exist in the current user hive, and we could modify it because we're the current user. So we could always allow the execution of Excel for macros until, I suppose, Microsoft deprecates them. So if you have Excel on your machine, you could bypass the device guard until these are deprecated. So let's move to a different technology. And this time it's going to be ActiveScript. And ActiveScript, which is the magic behind JScript and VBScript, is actually a generic Windows scripting technology or a standard. And it has already been the target of a couple of device guard bypasses, the Squibbly Do 2 and Squibbly something else. And it looks a bit like this. So there are two main components for ActiveScript. The first is the scripting host, which is an application that knows how to use various scripting engines implemented with ActiveScript to do a bunch of tasks. So and the other part is the actual scripting engine. And these ActiveScript interfaces are actually COM interfaces. So the moment you define and implement those interfaces, you're basically an active scripting engine and host. And what the host actually allows you is to use code from your application inside of the script. This is why Internet Explorer is able to use VBScript to manipulate HTML, because VBScript itself does not have any capabilities as such. But the moment it runs under the Internet Explorer scripting host, it is exposed to all of these capabilities. So the most common hosts and engines for ActiveScript on just a native Windows installation are on the host side, we have wncScript.exe, we have scrobj.dll, which is actually the engine behind scriptlets. We have MSXML 3 and 6, which run XSL transforms, and we have MSHTML, which is actually the Internet Explorer and also the HTA engine. On the script side, we have JScript, which is the most common version of JavaScript you will use like with Microsoft stuff. We have VBScript, and we also have JScript 9 DLL, which is the version of JavaScript that mostly runs in Internet Explorer and HTA, etc. Now, this list is not exhaustive, and you still have a bunch of other scripting hosts and scripting engines natively available on Windows. All right, so let's have a little look at how Device Guard is implemented in active scripting engines. And as I said before, what Device Guard does for ActiveScript is if your script is not allowed by the policy, you will only be able to create a very small set of predefined COM objects. So let's say you want to create wscript.shell, which is actually prohibited for a non-compliant script. So I'm going to write, first of all, I'm going to write just a bit of JavaScript, new ActiveX object, wscript.shell. This will then be passed to class ID from prog ID to translate the friendly wscript shell name to the class ID, to the GUID identifying our COM object. And this is passed by the engine to the host, which calls a function, a method called isClassAllowed. And it checks this class ID against a hard-coded list in a Windows library called WLDP, Windows Lockdown Policy.dll. And if this check fails, you just can't create the object. If it succeeds, you just get is allowed true, and you're able to create your object. So not every scripting host actually implements this isClassAllowed function. This is why there's a default success implementation in every engine. So if I'm trying to do the host as class allowed from the engine and just discover, oh, there's no functions, there's no such function, I will just continue creating the COM object and simply disregard device guard. So a couple of bypasses abusing ActiveScript actually abuse that. Just scripting hosts that are that don't have isClassAllowed implemented. And one such object is the ActiveScript event, the ActiveScript consumer, which is actually the Most common WMI persistence method. It's an event consumer that implements its own active script host, which is completely independent of the whole previous list. And it doesn't have this isClassAllowed function. But you could only use this as an admin, meaning that if you have admin, you could just run any script you want through strconst or the ActiveScript consumer, and the isClassAllowed function simply won't exist and won't be called. So all of your COM objects and all of your scripts will run as usual. And implementing this is actually absolutely identical to implementing WMI persistence, because it's the exact same process. You will just device guard will be completely blind to you. So all you need to do is create your script text, pass it as an argument to your scripting consumer, and then bind your consumer with an event that it should fire upon using an filter to consumer binding WMI object. And the moment the event triggers, your script will run uninterrupted. All right. So another type of unenlightened scripting host, host that doesn't have this isClassAllowed function, is MSXML. And this DLL actually implements XSLT transforms, which is a file format that allows you to basically change the format of XML files. And you could script that file format with embedded scripting. And these are actually hosted in MSXML itself, which doesn't have isClassAllowed. So the moment you can use an XSL sheet to transform an XML file, you could run the embedded script uninterrupted without ever looking at device guard. So there's a couple of ways to use XSLs, but I'll show a couple of less known ones. The first one is actually, again, a COM method of an Office application. This time it's Access. And Microsoft Access has a transform XML method that does exactly what you imagine. You have a data source, a transform source, which is an XML and XSL sheet. And the moment you call the function, it applies your XSL to your XML and runs the embedded script. So you could do this with 4 lines of PowerShell or with 4 lines of your favorite scripting or whatever language. And again, the moment you run this, embedded script runs, nothing looks at device guard, and all of your COM objects get created, and you could get arbitrary code execution. Another way to use XSL style sheets, again in a DCOM context, is actually by using Outlook, which has a create object method. And this method allows you to remotely create arbitrary COM objects. So again, I could create an MSXML, I could create an XML object, an XSL object, apply the XSL to the XML, run the embedded script, and it again runs uninterrupted. Now, when I first showed this thing, it was actually a lie by omission, because I didn't tell you how the scripting engine actually passes the class ID, the GUID of the object, to the isClassAllowed function in the host. And the answer is, there is no one single implementation of this, which was actually the source of a vulnerability in device guard. So let's look at 2 call stacks. The top call stack has the JScript9 scripting engine executing under the MSHTML scripting host. And here we have JScript9 executing, calling can object run, which then passes execution to the scripting host. And the function that runs is host query custom policy, which is a generic function that checks for COM object security. And MSHTML itself decides, oh, here I want to call isClassAllowed. And then it calls this, and if the class is disallowed, the whole query custom policy function returns false, and the object can't be created. But here we see that MSHTML itself is responsible for calling isClassAllowed. On the contrary, if you look at the bottom picture, you see that you have JScript executing can object get object from prog ID, and then immediately you see that is class allowed is called, meaning that JScript is itself responsible for calling is class allowed. So we have two different approaches. The one gives the responsibility to the developers of the scripting host. The other gives the responsibility to the developers of the scripting engine. And now we have basically a couple of different teams of developers. Each of them thinks that the other is responsible for a security feature. And what happens when we break those assumptions? As I said before, all of the scripting engines and scripting hosts, because they're all ActiveScript and they have the same interfaces, they could be used interchangeably, meaning that I could actually use something like JScript 9, which thinks that, oh, the developers of the scripting host will call my function and use it under, let's say, C-script, which thinks that, oh, I'm just going to give a pointer to the security function to the scripting engine, and then it will call it. And what happens when I do that is that nobody actually calls the function, because the two teams of developers were absolutely sure that the other team implements the call to is class allowed. And again, we have success by default. The function is never called, and our object is created with no checks whatsoever. And it looks like this. It's actually really easy to implement. So in the first example, we have me just trying to run a disallowed script, and I get an error when I try to create wscript.shell. And the second example actually shows me forcing C-script to use the JScript 9 scripting engine. And the moment I do that, is class allowed is never called, and I'm able to run my script as usual. And this is actually also, or this was actually also, this also worked for scriptlets, because strobj.dll also had the exact same implementation as C-script. So again, if I try to run JScript 9 under strobj, is class allowed is never called. And it's a bit harder to do because strobj can't really get a class ID, and it needs a friendly name, a prog ID. And JScript 9 doesn't have one. So all I need to do is to register one. So I just write it to the current user's registry hive, and I say, oh, now I have another engine called also JScript and not just JScript. So let's run a scriptlet with also JScript. And again, my code runs as expected. So this actually was patched in November, but look at this screenshot. We have a newly patched system with JScript 9 to which the patch was applied. And the top file is JScript 9, the patched version, and we see that the signature is valid, the signer certificate is Microsoft, etc., etc. The bottom picture is the vulnerable version of JScript 9, the one with the same vulnerability that I just showed. Now this file is still signed by Microsoft, and it has the same top-level certificate, meaning that it's still compliant with the same device policy, the same device guard policy that I put in place. And I'm, as the person who could execute arbitrary commands, I could just choose to execute the vulnerable version. And this is actually what Jimmy Bain or Bullhaps discovered, that you could take two of our bypasses, just bring the older version, the vulnerable version, to the machine, and just use that to bypass device guard. So who cares that the vulnerability got patched if the vulnerable version is still compliant for the policy. And the way Microsoft tried to handle this is by adding the suspect libraries to a specific policy that you need to merge with your device guard policy that will explicitly disallow the vulnerable versions. But that's not a really elegant solution because there's a systemic problem with device guard that this was only one example of, meaning that when you update and patch a device guard vulnerability, the maybe in some cases the vulnerable code will still be usable, and you could use stuff like uh, code execution vulnerabilities that were patched as device guard bypasses. So these, for example, are a bunch of are two Project Zero vulnerabilities, and these are the versions of the scripting engines that have these vulnerabilities. And again, as you can see, the signatures are valid. So I could just use use after free vulnerability on an older library that's still compliant, and again bypass device guard. And it turns out that the scope of this issue is pretty much everything, meaning that Windows doesn't really delete catalogs or explicitly disallow vulnerable versions of code when it updates stuff. And when you have a feature that is solely dependent on signatures and certificate, this means that in some way patching is meaningless against device guard because you could always use the vulnerable code. There's no privilege barrier. All you need to do is just sometimes register it in the registry, but sometimes maybe it's just a shitty executable and you just bring it from home. You actually don't even need to bring it because almost all of these are still on your patched machine in the WinSXS folder. So you just need to find it. So until this whole signature catalog hygiene issue is not solved, you will see many more issues such as this, such as the patch didn't really help me because I could just use the same vulnerability all over again. Right, so these were all of my bypasses for device guard, but actually, well, nobody uses device guard. Like, application whitelisting is terrible, so let's try to use whatever I just showed you for other stuff. First of all, these were a couple of alternative execution vectors, which are a bit weird. They really sometimes don't look like other stuff that attackers use. For example, I haven't really seen Office used directly for post-exploitation that much. And also, some of those are actually AMSI AMSI bypasses. For example, JScript 9 isn't instrumented with AMSI, meaning that if you run a script through JScript 9, you will never call any kind of AMSI function. So what I could do is just use the exact same exploit that I used with JScript 9 to bypass device guard. And this is still a valid AMSI bypass. And again, it's a single command line. And I actually found out that you could use, that you have a very similar AMSI bypass with another library, which is Chakra DLL, and that's another ActiveScript version of JavaScript because two weren't enough. Now, there's no AMSI for Chakra, but also there's no ActiveX or COM object functionality for Chakra. So, you can't create, if you can't create COM objects, you don't really need to monitor them. But CScript and WScript actually expose a method called WScript create object, which is just a drop-in replacement. So if you have, let's say, .NET to JScript or something like that, the only thing you need to modify in the script is to replace new ActiveX object with WScript create object, and then run it with the Chakra DLL library instead of JScript. And that's it. You are now invisible to AMSI. And you actually could stick these things together because now we're able to remotely inject code into Excel filelessly without any of the injection usual suspects because we're calling all of our functions from inside the process. We could use this from a Cradle that's invisible to AMSI, etc., etc. And actually, most of the stuff that I showed here is invisible to AMSI because when you run macros filelessly, they're never monitored by AMSI. So you could just use any of these, and most of the newer Windows 10 antivirus visibility features just fail against it. Anyway, so detecting these things is pretty easy because actually almost everything I've shown, because it's used in the context of device guard, is just command lines. You can't use it from your own code. If you could use it from your own code, you could probably run your own code and then you don't have the device guard problem. So it's almost everything is command lines, a bit registry monitoring, maybe a tiny bit of WMI monitoring, but well, I could also switch out the WMI stuff for other stuff. But again, you don't need any kind of special new visibility, and you could pretty much detect anything if you know how it looks. Now, the way I think the feature should develop is, first of all, you should really lock down Office because it's pretty ubiquitous. And unless you want to say that, oh, device guard is actually a server feature, you're going to have Office on your device guarded machines, meaning that you'll have basically a ton of device guards for every days. The second thing is implementing a generic solution to catalog hygiene is extremely important because if patching is meaningless, it means that you'll always have to you'll always have to keep track of every single vulnerability, not only the device guard ones, and know that, oh, this could be used against me, which again brings you back into monitoring everything. Also, I'm not sure that I found the only bug with the inconsistent implementations of device guard for scripting. So maybe if there was only one implementation, it would be much simpler to maintain. And finally, I just think that what if I want to use Java? What if I want to use Python on my machine? Like the next step for device guard, I think, should be implementing something more generic that will allow programming language and scripting language developers to just plug in device guard into their language. And then just say, well, if my Python script isn't signed, then just don't allow me to use C types or something like that. And anyway, I think that's it for my talk. I just want to say one more thing I want to add is there's tons of people researching device guard. They're extremely talented and they're doing some really cool work outside of the device guard. And you should probably follow these people on Twitter if you're in any way interested in application whitelisting or device guard. That's it.